Some of you have asked questions about the Gaussian elimination method for solving systems of equations. Now, what I want to stress to you is I'm having you use the calculator to do this. In other words, I shared with you two videos. One video was what the Gaussian elimination method is, and I did it by hand. And then I showed you the rref, row reduced echelon form, which is the Gaussian elimination, but the calculator does it for us. And I have a video on that, and what you need to do is watch that video for the calculator procedure. Now, I want to do another example with the rref, the Gaussian elimination, just to help you to see how to use that. Now, in the video, I showed a system of 3 variables and 3 equations. Now, I want to show you what happens when we have 2 equations and 3 variables. So it comes out a little bit different. But what I want to do is, first thing I want to do is I want to enter this matrix in the calculator. In other words, I've got the x, the y, the z, and then what's on the other side, which is a 1. So this is the x column, the y column, and the z column. And then down here I've got the 2, -1, and 1, and 2. Now look how this says. This says 1x plus 1y plus 1z equals 1. Down here, 2x minus 1y plus 1z equals 2. Now, what I want to do is put this in my calculator and tell the calculator to perform this Gaussian elimination on this. And let's see what we get. So I'm gonna bring this up here. So I've got over here, I'm going to do second matrix, and I go over to edit, choose this matrix 1, and this is going to be a 2 by 4. Okay. So then I enter these. I've got 1, 1, 1, and I guess it was 1, right? And down here 2, -1, 1, and 2. So if you go back and look, see I've got 1, 1, 1, 1, 2, -1, 1, 2. Yeah, so I've got that in there. Now once I have that in there, I'm going to do second quit, and then I'm going to do second matrix. I go over here to math, and I find the rref. Okay, there it is, rref. And I want to put in the matrix, this was matrix A, so second matrix A, there it is, enter. Now, look what I've got. I've got 1, 0, 2/3, 1. 0, 1, 1/3, 0. Now, I think if I can convert that to a fraction, and there it goes. So there you have it. So now let's see what this looks like. When we did the rref, what we got here, here's what we've got. We got the 1, 0, 2/3, 1, like that. And down here we got the 0, 1, 1/3, 0. Yeah, let me make sure that's the case. Yeah, 2/3, 1/3, okay. Now, here's what we've got. This says 1x plus 0y plus 2/3 z equals 1. See, because this is the x, y, and z. And then down here we've got 0x plus 1y plus 1/3 z equals 0. So see how our equation has been transformed. So here's what we do. In other words, we don't have one unique solution where these two planes intersect. So here's the game we play. I take this last equation here. I've got y plus 1/3 z equals 0. See? I got that from this right here. 1y plus 1/3 z equals 0. And then I get this. I get that y equals negative 1/3 z. Okay, now that's a start here. Now I go back and look at this one. I've got x plus 0 plus 2/3 z equals 1. So now I get this. I get that x is equal to 1 minus 2/3 z. So here's my solution. As far as the x value, it's 1 minus 2/3 z. That's what the x is. The y is negative 1/3 z, and the z is just itself. So in other words, there are an infinite number of solutions for this system of equations. Okay, these two planes, this is plane 1 and this is plane 2. These planes intersect not at a point, but at a line. And on this line, there are infinitely many points. You give me a value for z, and I'll tell you the y, and I'll tell you the x. Now, sometimes what they'll do is they'll say, okay, this is 1 minus 2/3 a, negative 1/3 a, and a. Sometimes you'll see a textbook doing that. You give me an a, and I'll give you the corresponding x and the y. Or in other words, you give me the z coordinate, and I'll tell you the corresponding x and y. Because notice that each one of these are in terms of z. But the point is, remember, it's just using the calculator. We're not doing Gaussian elimination by hand. So that's something to keep in mind. And I'm hopeful this will help you.